Welcome back, 8th grade. We're getting into reasoning and proof. Geometry uses a lot of our thought process in justifying why we're doing the steps that we're doing. This is part of the reason why I make you show all your work, because in all of those steps in geometry, you're going to have to explain why you did what you did. So let's get into it. All right, a proof is a logical deductive argument in which every statement of fact is supported by a reason. Now, reasons could be properties, definitions, postulates. Remember, the postulates are like the obvious things, and theorems, other theorems, or any given, and this is the big piece there, given facts. All right, and a theorem is a conjecture that is proven. So a theorem is something like we were talking about the angle sum theorem, triangle sum theorem, where we can prove that there is 180 degrees when you add up all three angles of a triangle, and that every triangle has 180 degrees. It can be proven. Whereas when we talked about like angle addition postulate, you're not really proving it. It just makes sense. All right, so tips for writing proofs. One of my biggest tips: to determine the reason, you want to look at the previous step and the current step. So what do I mean by that? Don't just look at the step you're writing and then say, okay, how did I, like, my reason is. Look at the previous step and ask yourself, how did I get from this step to this step? That's my reasoning. So we'll get into more of that, but that's when we're writing our proofs, determining reasoning. You don't want to just look at the step you're currently at. Look at the step before it and then our current step, and decide how did you get from that step to this step. So that's tip number 1. Tip number 2, each statement has to come from some statement before it. You can't just randomly take something out of thin air and now add it to your proof. Kind of like when writing a paper in ELA, you can't just randomly get to the conclusion and then randomly pull in new information right there at the end. When you write a conclusion, you are having to take it from your body paragraphs up above. So it's the same thing with a proof. We're finding our new steps come because of something before it. All right, so we're going to do an algebraic proof. That's going to be our first example. So how we do this is we draw two columns. right? And we have our statement and our reason. And for accelerated, this is not new for you. And then we're going to write what's given. So what is given to us is the equation. 3 times x plus 5 is equal to 45. That is given. That is my reason. It is a given fact. Now, I'm wanting to show that it equals x, that x equals 10. But I'm not writing that down yet. I've just got to go through the motion. My first step is to distribute. So my reason is that I'm using the distributive property. And so now I'm going to do 3 times x, which is 3x. 3 times 5 is 15. That equals 45. Now, from here, I'm using my subtraction property of equality. And so I'm going to subtract 15 from both sides. Oops, 15. And so now I have 3x equals 30. And again, that was from subtraction property of equality. Now I'm going to divide both sides by 3. So that's going to be the division property of equality. And so now that I divide, I get x equals 10, which is what I'm trying to prove. See? So that comes down at the bottom. Our reasoning will never be proof. Our reasoning will be how did we get to there from the step before. Okay? So again, I solved the equation like we already know how to. I just wrote why I was able to do each step. That's my reasoning. And so that's how that works. In our next video, we're going to talk about geometric proofs and how to use actual like theorems and those types of postulates and properties to solve those proofs. So I will see you on the flip side.